This video we're going to be introduced to the sine rule. Before we get started, I just want to remind you about how to label angles and sides of a triangle. This is stuff you should know already, but we're doing a quick review of that. If we have triangle ABC, if this is A here, this vertex, B here, C here. So that each of those vertices have capital letters. Now, when you label vertices of a triangle, you use capital letters. Likewise, we could call that angle A with a capital A. So we'd use the angle symbol. Angle B. Angle C. Notice the capitals. We always use capitals for vertices or angles. Sides are in lowercase. Side A would be written like this. Side A is opposite angle A. Side B would be written with lowercase b, and you can see that it's opposite angle B. Side C is lowercase c, it's opposite angle C. That is important. So far, for our work in trigonometry, we've dealt with right angle triangles like this one here. And we use our sine, cos and tan ratios. Sine, cos and tan ratios to solve problems to do with these. For example, if angle B was needed and we knew that side B was 3 and side A was 6, we'd be able to use the sine ratio to calculate that. So let's quickly do that. This is not new work. So we would have sine theta is opposite over hypotenuse, which would be, in this case, side B over side A, which would be 3 over 6 or a half. So to get theta, we take the inverse sine of a half, and that's 30 degrees. So that's something that should be straightforward by this stage. I'll present you with a different triangle ABC. This one is not a right angle triangle. So ABC is the blue triangle there, it is not right angled. So what do? We can't use our ratios anymore as we have before. We can't use SOHCAHTOA. We can't use Pythagoras' theorem. So does that mean this is completely unsolvable? No. What it means is that we're going to introduce you to the sine rule. And the sine rule, and notice how it's not the sine ratio, it's the sine rule. And later on the cosine rule, which gives you extra ammunition, if you like, to deal with non-right angle triangles. So they're more complicated formulas, but they can deal with any triangle. It doesn't have to be right angled. Some important notes. So the sine rule holds for both acute and obtuse angled triangles. This is particularly important. By doing lots of questions you gain experience, and you will know when to use the sine rule. Use the sine rule when you know one side of the triangle and one angle opposite that side and another side length or angle. So what do you need? You need a side, you need an angle opposite the side, so you need an opposite angle to the side, and one other side or angle. That's very important. By doing lots of questions, that'll help you remember this, so make sure you've got this noted. We're now going to develop the sine rule. So first of all, using this non-right angle triangle here, we're going to look at triangle CPB. Now you notice that we split the main triangle into two small triangles, and they're right angle triangles. So CPB, so CPB, the right hand triangle. So if we want to look at angle B here, we can look at sine B. This is our regular sine ratio. So because we're back into a right angle triangle, we can use our regular ratios to develop this. So sine B is opposite over hypotenuse, which is H over A. H equals A times sine B. So I'm going to call that statement 1 because we're going to come back to that. If we now look at the other triangle CPA, we've got CPA, we've got sine of A is opposite over hypotenuse, which is H over B. Rearranging, we get H equals B times sine A, and I've called that equation 2 or statement 2. Have a look at what we have. H equals this and H equals that. So both equation 1 and equation 2, the right hand side equals H. So that means that this equals this. So we write therefore A sine B equals B sine A. They're equal to each other. We can rearrange that now, and we're nearly arriving at what's called the sine rule. Rearranging A over sine A equals B over sine B if you do some algebraic rearranging. Or if you did it in a different method, you could get sine A over A equals sine B over B. That's basically the sine rule. The full sine rule is here. And this is it. And you can write it upside down or the right way up, it doesn't matter as long as you're consistent. A over sine A equals B over sine B equals C over sine C. You don't have to use, in fact you won't use all three parts at the same time. You'll use only 2 at a time as needed. It depends on the information given in the question. You can also write it upside down. Sine A over side A equals sine of angle B over side length B, which equals sine of angle C over side length C. That is the sine rule in full form. Make sure you get that copied down. We're given a non-right angle triangle, and we'll call that ABC. And we're given that that's not right angle, and we've got to find the angle theta. So we have to find this angle. So we can see if we can use a sine rule. Remember, let's check the information. We have one side length. Yes, we do. We have 2 side lengths. Do we have a side length and an angle opposite? Well, we have this side length and that given, yes. And do we have one other side or angle? Yes, we have a 9. So yes, we can use the sine rule, and we probably should use it because the sine rule is fairly straightforward. So we have to find angle theta. Note that angle theta is the same as angle A. So I'm just going to replace the theta with the A. And that way it's consistent with the sine rule. So, if we're trying to find the angle, the sine bit goes on the top, so I'm going to use this version of the sine rule here, sine A over A. Now the reason why I'm starting with that is that we're trying to find A, so it's heavily involved in this question, and we know 9 here, we know the 9, so that's side A, so we know those. And we got angle B, so I'm going to include the B, and we've got its side B as well. We don't know anything about C, so I'm not going to include it. I don't need to. So that's the version of the formula that's going to be the nicest for us. So remember, you have to sometimes supply your own sides, the labels for them, and the angles. Alright, you need to be prepared to do that. Sine of A equals, okay, side A, which is 9. So sine A over 9 equals sine of angle B, which is sine of 83 degrees. Sine of 83 degrees over B, the side, which is 10 centimeters. And we just need to solve that. We want to get sine A by itself, so we need to multiply both sides by 9. What you do to one side, you've got to do to the other. That's the inverse of dividing by 9. So we've got to times both sides by 9. Thus, we need to times this side by 9. Now, if you times a fraction by 9, you're really just timesing the numerator by 9. It's your basic work on fractions that you should be very familiar with by now. So we do the right hand side, get our calculator and crunch that. Or you could not crunch it yet, you could just go, well, I need to do the inverse sine now as my next step to both sides. Apply inverse sine to both sides, and so the left hand side would be A. I'm just going to move this over a bit, this equal sign, because I'm not going to have enough space. Okay, so inverse sine of sine A is just angle A, which is what we're trying to find, and that would be the inverse sine, put in brackets, of what we had on the previous line. There we go. And then we crunch that in the calculator, and I get 63.3 degrees to 1 decimal place, assuming that's what they've asked you for.